Alright, now let's turn to page 108 and do the structure question 31. So in this question, it asks us to make lead azide by using sodium azide, right? And it says that the chemical formula for PbN3O2 is the lead-2 azide here. So we can be able to derive a balanced chemical equation from the question here. Alright, let me add the states now. The states for this one is aqueous, solid, and also aqueous. Alright, the first step. What method would you use to separate lead azide from the reaction mixture? The lead azide is this one, right? If you want to separate it, and if we see from the states, since PbN3(2) is solid, and the other products here, either reactants or products here, they are all aqueous, right? So what method can we separate solid from aqueous? It should be filtration, right? So in this is solid, other reactant or product, reactants or products are aqueous solution. We can separate by filtration. So for the filtration method. And now let's take a look at question B. How about I duplicate one balanced chemical equations and put it here. So for question B, it says that we have 10 grams of PbNO3(2). So let me put the mass here. 10 grams. And mixed with 5.2 grams of NaN3. Solution. What is the mass of PbN3(2) produce? Alright, for this part, remember, if the question is given you 2 mass, then we have to determine the limiting reagent, right? If we want to know the limiting reagent, then we have to know the ratio to coefficient. So if we want to know the ratio firstly, what step should we do? We should find the moles for both reactant here, right? We have mass, molar mass, and also moles here. The molar mass for PbNO3(2), let's do it all together here. It should be 207.2 plus 2 times brackets 14.0 plus 16.0 times 3. The final answer should be, type in a calculator, it would be 207.2 plus 2 times brackets 14 plus 48. So when we add it all together, the answer here is 331.2 gram per mole. Similarly for the right one, it will be 23.0 plus 14.0 times 3. It will be 65 grams per mole here. But better to write 65.0. So now, if you want to calculate the mole, again, mass mass over molar mass, right? So the left one should be 10.0 divided by 331.2 gram per mole. The answer here should be 0.03019 mole. And then also the right one, it will be 5.20 grams divided by 65.0 gram per mole. The answer here should be 0.08. For significant figures, then it would be like that. Alright. And now let's compare the ratio to coefficient, right? Where's the ratio to coefficient? Then the coefficient here should be exactly equals to mole ratio. What is the number in front of the two compounds here? One is 1, another should be 2, right? If we want to calculate which one is the limiting reagent, we have to know the lowest ratio to coefficient, right? Then we do some calculation of 0.0319 divided by 1. Here is 0.08000 divided by 2 will be 0.4000. Comparing these two, which one will be smaller, which one will be greater? The left one is the small one, right? Then we know that PbNO32 is the limiting reagent. So if we want to calculate the PbNO32, if we want to calculate the PbN3 brackets 2 here, which reactant should we use here? Should we use the limiting reagent or use another one that's in axis? Think about it. So we should use limiting reagent here, right? It's because this one here, as we calculate, this one is in axis, which means the number given here is this. There will still have some remains after the reactions. So can we directly use this, like the grams, for us to calculate? We shouldn't be, right? We shouldn't use this answer. And now we use the moles. We use the grams from PbNO32 and also the moles here. Alright, if we want to figure out what is question asked about? It should be the mass, right? If that is mass, then we have to know the mole first, right? Then let's take a look at here. So we have mole ratio of this as 1. What is the mole ratio of that? This one is also as 1, right? This one is 1, and this one is also 1. Then we know that if that's 1 to 1, the ratio, the mole here should be 0.03019 mole, right? What is the molar mass for PbN3 brackets 2? 207.2 plus 6 times 14.0. The answer should be 291.2 grams per mole, right? How can we calculate the mass? Again, use mole times molar mass, right? The mole here should be 0.03019, and times the molar mass will be 291.2 grams per mole. The answer here should be 8.79 grams. And this will be the final answer for question 31, part B.